Well, I wanted to, first of all, thank you for inviting me to give this presentation because when we started our firm about 20 years ago, we had this crazy aspiration to reluctantly and with a great deal of suspicion embrace technology. And of course, at that time, it was a very different picture. But I wanted to tell you that since that time, our firm has grown to about 75 architects. And I still have this healthy suspicion of technology. I think that not unlike most people of my generation, we started out more interested in architecture as craft and architecture as something that you could tangibly hold and imagine, and that had the kind of desire for atmosphere. And it involved the kind of bringing together of materials. So early projects such as this little studio really were about an exploration of those themes. And that led to sort of medium-scale projects such as McKinsey Building on Charles Street, which, the closest that it ever came to needing technology was that maybe we did a little bit of work with early CAD. As projects got more complicated, such as the Schulich Building here, we embraced a little bit more the idea of curves and complex building envelopes, and I think that working in joint venture with larger firms also made it necessary for us to invest more heavily in sort of what I would call vanilla technology. And it was important. It was important because the scale the projects demanded it. The clients started to say, what are you going to do? All of that was necessary. This is a small intervention at the AGO, which you'll know on Beverly Street was another one of our projects. I'm going through these quickly because I want to talk about the kind of history of how we jumped into more sophisticated use of technology. This was a project at Waterloo for the School of Pharmacy, and suddenly, patterning started to become something that was of interest to us, especially this kind of floral pattern and complicated kind of setup of the curtain wall, and the use of some of the technology that we had started to transfer over to the ability for us to orchestrate, let's say, this is almost 10 years ago now, complicated systems of assembly of patterns. The law school, as you know, is now going up and involves a similar approach. This is all to do with kind of an idea for something interesting, but at the same time, something that involves a sustainability story, how the facade changes from east to west to north to south, and the degree of opacity that enables. And the Ivy Building, which is just a building that we just completed about a year ago here, also, again, very basic systems of Revit and other CAD systems. So nothing that special. What happened was in these larger projects, and here's one, for example, for a house we did for Mike Lazaridis, which was entirely fabricated in large pieces and brought on site on the shores of Lake Huron, forced us to develop our own curtain wall systems and have them fabricated in France, in this case, and brought on site. Complex pieces of stone that were digitally carved started to come. And so this kind of interface, this kind of early exploration of how the technology started to enable us to explore more complex forms began to emerge in the office. And a lot of this, and I think this is what I try to tell in these talks, is that technology really is only interesting to us if it enables us to design more interesting things and bring forward propositions that solve problems, but also, deliver things that are going to be able to be realized within the same constraints of budget that we face on other projects. So, basically what I'm saying is, if it delivers something interesting, cool, and is able to do that within a certain budgetary constraint, it becomes interesting. And so this was an eye-opener, and we started to actually involve more advanced BIM systems to deliver a very complex project that had to be essentially assembled in 3 dimensions and brought in pieces and built in a very complex site. Now, so we have a myriad of curved pieces of stone that are cut and assembled and put together. And then the last one, which is at the corner of Bloor and Young, you know that this is going up right now, has a complex facade system that was essentially manufactured in China, and again, was the result of this kind of communication between fabricator and 3-dimensional modeling. Now, I just bring in these projects because really the core of my presentation today was a project that all of this work circled around for almost 12 years, which is the Baha'i temple in South America. It's a project that we entered a competition for in 2003, 185 entries from about 80 countries, and was an early idea, really a conceptual idea of this beautiful passage from the Baha'i writings on this idea of light, and sprang from a kind of a desire for a building to manifest an idea of what we called structured light. This idea, you know how plants, for example, they move in the direction of light. This is a young boy who did this beautiful time lapse of plants and how they actually, if you move the light from one side, they start to lean towards that side, and then you move the plants on the light on the other side, and the plants begin to move in that direction. And we love this idea that a building somehow could not only respond to light, but could capture light, could somehow hold the light. And this was a sister project to the first Baha'i temple in North America, which was built in 1930s, which is called the Temple of Light in Chicago. And we said, you know, what we would like to do, this is a building that takes light from outside. It goes through this extremely beautiful perforated skin and hits a layer of glass which you don't see, and then goes through another perforated layer of skin on the inside. And so the idea of light passing through the building, being held by the building, was something that we were just completely enamored with by this project. And it being the South America temple, we thought, you know, this is a very interesting kind of sister temple, sister idea for the South America temple. And this was the last temple, the continental temple to have been built, which is in New Delhi, India. So, you know, these were tough acts to follow. The Chicago one took 50 years to build and essentially spawned the precast industry. It was the first precast building in all of North America, and the whole way in which the filigree was built was invented by this industry and then spawned the whole industry. This project is similarly kind of breathtaking in the way that it was built by the kind of low-tech construction armature of New Delhi, an extraordinary feat that that we were to follow. So here, we're entering this competition. How do we enter? We began, and this is why I wanted to talk about this. You would imagine, why am I speaking to this at a BIM conference? Because I want really to put forward this idea that really we don't really care what tool we use. We just want somehow to find our aspirations manifested. And so we began the project by thinking about what the atmosphere of this temple would be like. And of course, looking up at a canopy of trees, maybe the archetype of temple architecture would be a canopy of trees, these paintings of structured light, this resin castings, movement, the tonne chair, which is such an extraordinary sense of completeness in its form of curves, fractals, which is a whole other exploration that's happening in architecture. I love this basket because it described this idea of the imperfect perfect, this kind of non-Western idea of perfection, which the temple, the Baha'i temples, the mandate is that it must be as perfect as is humanly possible. And robe paintings, because we wanted softness. We wanted the temple to feel soft. And this idea of movement around a center, which began really in these earliest sketches and model explorations, little thumbnails, exploration, which is how we begin many of our projects. That really we don't trust the screen as much as we trust the eye and our hand and what we hold. And so these are the ways which we begin a lot of these early markings, these double skin explorations you can see here, and looking up over alabaster skins, a kind of a myriad of model explorations. Then, this is now 13 years ago, we wanted softness, we couldn't find it. We couldn't find it in what we were making, and the suggestion was that we dive into a program called Maya, which, as you know, is animation software. And we threw in what we had in the mirrors and began exploring this double skin, pushing it in weird ways in. You touch it, it was like gelatin, right? You know this program. It just moves like gelatin, in, out, and crazy forms started to come. But then pushing it back and forth, using the hand and the eye and models all the time, and emerging kind of ideas of double skin, this kind of net idea, this kind of softness. You can see the robe paintings, you can see the idea of both symmetry and completeness and movement, which was very exciting in this one image. And then how to make it, pushing it around again, and then eventually coming up with this as the final model, which we then, early days, we only had one person that had a 3D printer, if you can imagine, in the whole city, way up in Concord, and we had to rush up there and explore the idea of how to fabricate this model, which the wings started to explode in the oven, and eventually we submitted. We had to go to Haifa, submit the design that we came up with, and we were accepted, which was great. But then now we had this entire design in a non-measurable system with such complex curves, and we had no way of knowing how even to describe it, let alone fabricate it, which was really, we thought we had it all buttoned down. You can imagine, like, we got this one. And then we discovered it's not so easy. And we began in the early days to explore different systems. We put one person in our office, I think it was, Justin, how long was it? Maybe 2 months, just to explore what was available. And the conclusion was that we had to dive into CATIA at that time in order for this to be somehow described. And we sent 7 people down to Gary Technology. They were the only ones that we knew of that were combining architecture with CATIA, and that were offering, you know, they had a kind of open office approach. We went down, and out of the 7, in fact, we sent some very senior people. Some of our most senior people that were working in our office went down, and then we kind of kicked in the total junior, which was Justin Ford, just as a kind of a, let's see, why not? And the only person that emerged being able to use the CATIA was Justin Ford. So it's great to have Justin with me and to be able to talk to you about the ins and outs. But Justin has now been on the project for over 12 years and has held the kind of reins of the CATIA model throughout all of its phases, through the time when we had to hire people from the automotive industry to help us actually input the design, to the whole business of figuring out how to build it and engineer it and the skin, to then working with a whole procurement dynamic, and then eventually to deliver it. So he's here to answer those questions. But what you'll see is that the entire project, and here are slices, horizontal slices, from the foundation system coming up and through and showing you how complex the geometry becomes as it shifts up. Of course, you know, the red in this map shows the most active seismic zones in the world. And that little sliver on the left of South America in deep, deep red is Chile. So not only did the building have to be built, but it had to be defendable by several expert reviews on the kind of its ability to withstand. You saw that recently. Santiago, near Santiago, had one of the largest earthquakes again. So the combination, whatever I'm presenting to you, it's all one thing. It's not just a building, it's not just an envelope, it's not just engineering. It was all one thing and was continuously designed as one thing. But what I loved and what we were very excited about was the way in which each wing had a kind of complex geometry, a kind of fractal geometry, which I wanted very much to hold. And you can see here, it's described here, and how that is put forward as a kind of an idea on the skin. And when we went to, frankly, when we went down to visit the various people that were helping us with the technology early on, they wanted to make that geometry essentially all rectilinear tiles, almost like a bathroom surface, you know, where you take a complex system, but you just create a kind of a simple rectangular tile system that covers the surface. And what we wanted to do was, no, we wanted actually the entire architecture would be determined by the structure. And the structure would follow the kind of inherent logic of this space frame that would be part of this geometry. And then everything that follows the structure would have to follow the kind of interior discipline of what was set by the steel. So I like that very much. And in fact, it was something that we were inspired by the designer at Apple, who had spoken to me just about doing a house for him, and talked about philosophically, if you kind of break open an iPhone, the little round thing, you can see the kind of reason why that manifests itself in and buried into the kind of interior logic of how it works. And I like this very much in the kind of expression of the architecture coming about by that, so that the pattern on the outside is determined by the structure. And so this was Gary's first attempt. You can see the difference, and we threw that out. Every object, as you know, is described independently in the system. So all of the exterior skin, every piece of it is described as an object. Everything on the interior is described as an object. Everything that is part of the structure is described. And so this allowed us to do what the client wanted, which we can get into at length, but they wanted a GMP for the whole project, and we had to deliver it with a guaranteed price. And I was saying that we have now, it's almost all built, and virtually, I think there's only about 3 change orders on the whole project that were non-client related. So it's really quite an extraordinary thing that the technology enables. This is not just allowing for crazy forms, it's allowing for the exploration of serious architecture, but also delivering it within a format that tries to play down the risk. And I think this is really what I wanted to deliver. If there's any one singular message to this conference, it's that we have to get out of this idea that this is about just kind of allowing the designers to do their stuff. No, this is about allowing us to solve very engaging, interesting problems in a new world and delivering them really within a cost that the client sets out that's difficult to meet. And so this project had to be delivered for the shell at roughly 18 million euros. And we were not allowed any deviation from that. And so we had to work constantly to make that happen, and we're able to bid it around the world with this approach. And you can see the CATIA has every single piece in it, and the structure was then taken and described, and the pattern of the outside is determined by the space frame pattern on the inside, which was tested early on. These are scale models, 1/6, just to prove to ourselves the steel fabricators would not believe. This is now, you have to remember, this is about 2006, 5 that we were building this model. And the fabricators themselves here would not believe that the CATIA would actually close. And so we had to prove through the making of these models, we had to prove to them that the technology actually was precise and would enable closure. So every little piece here you can see in the model was fabricated with some accuracy. And that was our own testing ground. Eventually, the concrete work was done by Chilean trades, of course, and there's a seismic isolation system that was designed by 3 universities, quite a complex undertaking in and of itself. Pendulum system, you know, so it can move up to 60 centimeters and come back to its original center. But the idea of this, which was, I think, a really interesting, perhaps even somewhat new in our experience, procurement model, was that we went both extremes. We bid what we could locally in the most low-tech form possible. We have an entire group, we have a project manager, we have a lot of volunteers around the world that are very, dedicated to help build what they can as part of this. And so a lot of the kind of site work, infrastructure work, concrete work, all of that is bid out at the most kind of low-tech spectrum possible. And then we basically cut out the middle and went super high-tech on the rest of it. So single contracts as much as possible for the exterior shell, and then one contract also for the interior, all prefabricated, all brought in pieces directly from various fabrication shops and assembled on site. So the structure, which was a kind of a genius collaboration between our office and Gartner Steel and Glass out of Germany, they essentially took our system, which was a frame and a subframe, and collapsed it into a single frame. And what that meant was that we had to take all of the kind of complexity and absorb it in the fabrication of these nodes, which are milled from 4-inch thick or 10-centimeter thick high-strength steel. And you'll see each one of them has a different shape and plasma cut like this, you could see, and then taken to another shop, you know, in this incredible robotic 5-axis CNC machine that was specially designed to be able to deal with the kind of strength and forces that this operation required. And that system would, through kind of machine to machine, each piece obviously was described and delivered and fabricated and then numbered and then brought towards the steel fabricators. And you can see here how each piece was created and the kind of complexity. It's just mind-boggling when you actually go through it, each piece and what that had to do. But really, at the end of the day, it was mostly an engineering issue, and once it went to the fabrication arm, it just simply was being extremely organized, and every piece was numbered, stamped, delivered, brought, and assembled. And you can see here the kind of the layout in the shop of each of these pieces. And then the fabrication of the steel was really another wonderful thing to watch, because the Germans took each wing and basically put it on its side and transferred all of the points down to a horizontal plate, which they then described, mapped out, and then created a system. So you can see here, but what you don't maybe see is that the entire floor is this etched steel plate with all of the various coordinates and numbers laid out. And then each piece was, you can see, assembled. I love this part of it. Certain pieces were so important to be done perfectly that this is the oculus, the kind of eye to the heavens that had to be done and built absolutely perfectly. And only one guy, this one employee of Gartner, was the only person that would be allowed to do it. So he built the oculus. Cast glass, a material we wanted light to go through the surface. Another kind of system, we set up a little shop here, 7 kilns. We broke the glass in a certain pattern, melted it to a precise temperature, each one of them computer monitored to create this wonderful pattern, sheets and sheets of it, and then of course everything then again through the CATIA is delivered as a pattern to Germany, water jet cut, each piece numbered, and then the fasteners are attached to the back, and you can see the frames, each numbered and then assembled on site. Again, the only way to do this within any kind of reasonable approach is, you know, embracing the idea that the technology is helping us. And what I love, of course, is that there is no single drawing, it's all one thing. And in that sense, the building has always been one thing, whether it's a steel piece or whether it's a glass piece, or in this case, some of the curved glass pieces, which were extraordinarily, if there was a single most difficult thing to do, it's all the curved glass pieces, which each mold had to be kind of reverse, cast, and then delivered from one place to another place, and then the glass pieces were all slumped to precise shapes. And they're built to a precise shape, but they're built large. And like you do with, I guess, the dough around the pie thing, you have to trim it. And so they were all sent like this to Germany, where they were cleaned up and then cut to a precise shape and then nested and brought on site. You can see the kind of extraordinary reflection. So the temple has this ability, which we wanted very much, to absorb the light, this idea of structured light. And you can see the light changes with the times of the day. And here it is, early morning light, and how the light goes through. The interior is translucent stone, beautiful stone from Portugal, which we found in a certain vein in a really extraordinary hunt, and another whole story in itself. But again, I think for you, you should know that we could not have done this if we had not had a kind of a machine-to-machine approach. You get the slabs like this, but they're each one then cut precisely and nested in a similar way to the glass, so that we have this idea of the light going from the outside, the light going through the structure, and then hitting the interior surface in this way. And of course, when it reverses, it becomes a whole other surface with the light hitting it. The curved stone, similar, really very similar to other pieces, was all done machine to machine, and each one described. You can see them here. There's templates that were created to check ourselves and make sure that the shape was being fabricated according to the shapes, and then each one is put up in this way again. So these are the early models and the study of the section. And then the final result, this is the structure going up in Santiago. You can see the kind of the patterning even that the structure creates, anticipating the pattern of the glass and the stone. And then this is the first thing to have gone up was this stone on the interior and the kind of quality of light coming through it and the patterning for each of the shapes. The entire temple is held up on these 9 columns, and this is the system for the cladding of the columns. The oculus going in. The gardens, which is a whole other story that I could talk to you about, the design of the gardens around the temple. This shows you the kind of the scale of the interior and the wings reaching up and how that's being clad with the glass. Good. Thank you very much.